All right, so, okay. What I'm going to do is I'm going to go through all the theorems. And the theorems is going to be very critical for you for AP exam. By understanding the theorem question, because theorems question is going to affect you in the long term. So you got to think about how do you understand the theorem. Most of people will prefer to avoid those questions. I don't prefer to avoid questions. I personally think those are easiest questions, but students need to find out how to do things. So, first of all, let's talk about intermediate value theorem. And I know this is a review, so intermediate value theorem. Do you guys know what's intermediate value theorem? Yeah. Okay, can you tell me what kind of condition need to be?
Continuous.
Huh?
Just continuous.
F of x is continuous, okay?
And there exists a value k between a and b such that...
There's actually a second condition. There's actually two conditions.
Is something to do with the endpoints?
F of A does not equal F of B.
F of A does not equal to F of B? Yeah. They cannot equal each other. Otherwise, intermediate value theorem does not work because it would be like this and there's no value in between. So F of B. F of A does not equal to F of B. So if that's the case, and then C is between, so C is between A and B, right? C is between A and B. So this value C has to be between A and B. So there must be F of C. Well, there's technically one more way to think. I forgot to write it. So let me see. Intermediate value theorem. Okay, so F of A, so close interval between A and B. F of A does not equal to F of B. And K, well, we're going to say K is between F of A and F of B. So there was a result is at least one C such F of C is equal to K. So basically this is a water bottle problem that we talk about. It must go to a label. Hi Liam. Are you mad at me? No. Okay. I know you're mad at me, you don't want to show up anymore. Okay, so result at least one C such that F of C is equal to K. So this is intermediate value theorem. This is very, very powerful theorem, and things like that is going to come in very, very useful. Okay, I do want to talk about two definitions. There was two definitions that also involve because they do a combination of those two questions. They will ask you like something like definition of derivative. So definition of derivative is going to be, anybody know what's definition of derivative?
F of X plus H.
F of X plus H. And then what?
Minus F of X.
Minus F of X. Over H. There was something in the front. Limit H approaches 0. But what is that equal to? Yes?
F prime of X.
F prime of X. That's actually the most important part. Everybody remember this part? Like everybody remember this part, but nobody remember this part. How about definition alternative derivative? Of alternative? F prime of what? C is equal to what? f of x,
Minus f of c.
limit x approaches c minus f of c over x minus c. So there was a definition of derivative, definition of alternative derivative, and there's intermediate value theorem. And those are the things that AP exam keep on consistent asking this. Also before that, also there's the pyramids, right? The continuous and differentiable. So let's talk about continuous and differentiable. What's the requirement? What's the limit to exist? So limit exists. It's only when limit x approach to a from the left of f of x equal to limit x approach to a from the right of f of x. So that means limit exists. And next thing is continuous. Well, continuous, there was three things, right? Continuous is limit x approach to, f of a must be defined. And two is limit x approach to a must exist, which is this part. And third is limit x approach to a of f of x must equal to f of a. And far as the differentiable goes, you have to have all those things prior, right? And then what's the only thing difference? What's the only thing different?
Limits equal each other?
Limit equal to each other, good. So then f prime of, not limit equal to each other, but f prime of x equal to each other, right? F prime of x equal to each other. So then you have all those things, limit exists, continuous, differentiable, and you have the whole picture of everything going on. Now, when you study for AP exam, this is a part of your theorem I will study together to understand how is those things connect to each other. Today, I would like to introduce a new theorem, which is called mean value theorem and rules value theorem. So we're gonna start with rules. Rules is actually super easy. It's very, very common sense. You don't need to be a genius to figure out rules. I don't even need to be a mathematician to figure out how rules theorem works. But it starts with something that is a little bit different. Also, do you guys know there's a three place a function is not differentiable? Can you tell me three place a function is not differentiable? So three place a function is not differentiable. Yes.
Vertical asymptote?
Well, yes, but that's just gonna that's a
Oh, like when the line's a continuous line or it's not differentiable?
well, okay, so if it's not continuous, automatic means not differentiable. Does that make sense? Because you need to be a continuous to be differentiable. So what I'm saying is that three places where a function is not differentiable, where is continuous. Robert? Vertical tangent. Good. What is second place?
Sure.
Look.
Oscillating the thing, the sine over 1 over x.
That is that part is not in the one of the things, but there's sharp turn, yes. There is a one last place though. Yes.
Endpoints?
Endpoints, correct. And this endpoint becomes a big problem when it's talked about mean value theorem or rules value theorem, because they keep on stress those things very, very fine-tuned. It's very, very small places. They will make sure that you get this. And we can talk about those questions in a second. So endpoint is definitely not differentiable because there's not both sides. So it's an end, it's not differentiable. So therefore, your mean value theorem and rules value theorem really talk about that. But let's start with talk about rules theorem. A rules theorem is going to be Rules theorem is gonna be so important that people make sure that you understand. So the first condition of rules theorem is what? So let's talk about conditions. Nobody can tell me?
Function is continuous.
It's continuous, so f of x is continuous. But not only in anything, f is continuous at a and b, close bracket. You're not gonna have open parenthesis because that won't be continuous, so it has to be close bracket. But what else? What else?
Differentiable.
Differentiable, good. Now, put in mind here. In which interval?
Close bracket A to B.
Not close bracket,
Open bracket.
because endpoint is not differentiable. So therefore, see this case come back to here. The endpoint is not differentiable, so A and B, so therefore it's not including A and B. So sometimes you get the mean value theorem or Rolle's value theorem, and you got to the endpoint, and that the endpoint, it does not count. It should exclude it at all costs. So those are the things that you should think about. So now, f of x is continuous, f of x is differentiable. Now what else? They just saying if fa, the last one is fa equal to fb. Unlike intermediate, is fa does not equal to fb. If you say fa equal to fb, there must be f prime of c is equal to 0. So you got 1, 2, 3, and this should be in red. So f, sorry, this should be in red. There's still condition. F of A is equal to F of B. F of C must be equal to 0. There's at least one C, at least one C, at least one C. So at least one C where F prime of C equal to 0. So let's see what it makes sense graphically. Does that make sense? Let's just say if I have a function, and I have an A here and I have a B here, and they both f of A, f of B are equal, so this is going to be the same height. And it's a continuous differentiable. Why is it continuous differentiable? Because I'm going to give you one situation. It has to be continuous. We know otherwise there's nothing can work. But why is the second condition is very, very important? Why did I say it's differentiable? Yes.
Or else could differentiate.
Well, yes. You can. So let's just say if I have this situation, like let's just say if I have this situation like this, right? As C is not differentiable, but then f prime of C is equal to undefined in those cases. So this is actually f prime of C is undefined. Right? So it has to be differentiable. That condition has to be there. Otherwise, you can have a cusp in between, whereas f prime of C is undefined, not 0. Right? So if that condition does not exist, then you can come up with a situation where f prime of C is undefined instead of not differentiable. Instead f prime of C is equal to 0. So there was at least one C with f prime C. So in this case, the rules value doesn't work. So rules does not work. Okay, it does not work. So in this case, it does not work. Why it does not work? Because it's not differentiable. So that's why you need to understand. Okay, so those are one of the first cases. Second case, that f of A equal to fb. Well, so where Rolle's theorem works, let's talk about where Rolle's theorem works. Rolle's theorem is going to work at this situation here. So where work? So work at if it's differentiable. So it's differentiable. So let's just say A and B. And it work. So they are continuous differentiable. First example, I can come up with just some simple function here. Here you got a horizontal tangent one. F prime to C is equal to 0, which is true. Can it happen more than once? Yes, absolutely. Can I have like this? It happened twice, C and C, right? It can happen twice. It can happen 3 times. As long as you have infinite amount of oscillation and they have to be differentiable, that means there's no cusp, there's no sharp turns, and things like that, F prime C has to equal to 0. So that is true. So those are the things that you have to say, okay, well, there's no other situation I can create where F prime C does not equal to 0. It has to be true. This has to be true if you have those conditions. Now, some of you guys remember mean value theorem. The reason why mean value theorem is kind of a copycat. I feel like it's a copycat. Why do I say it's copycat? I say, so rules as a mathematician is 100 years before Lagrange. Lagrange is after rules. So he kind of look at rules. He says, let's create a situations. That says, let's limit down the conditions. Let's get rid of this condition. FA does not happen to equal to FB. Then you say they don't have to be in the same height. Yes, they do not have to be in the same height. Okay, they do not have to be in the same height. So rules kind of help construct the mean value theorem. So the mean value theorem says it's very simple. So and this one is always tested. It didn't matter what AP exam or college exam or UCF exam. This one, if it doesn't test it, it's not possible. Okay, mean value theorem. This is like MVP. This is like MVT, right? MVT. It's like, I think it's MVP. It's like most valuable player. But this is like most valuable theorem, I think. Because this one is actually, he's copied it. He copied it. We're going to show you why he copied it though. It says F is continuous between A and B. And second, F is differentiable. Open parenthesis, A and B, so now including A and B. And then they says, the result is F of B minus F of A over B minus A equal to F prime of C. So it's equal to that. Now, I'm going to give you a couple name of this. This is a slope of secant. And this is a slope of tangent. So, when slope of, there must be a one value where slope of secant equal to slope of tangent. At least one value. So, at least one C. At least one C. In terms of other situation, other vocabulary, slope of tangent can be described as instantaneous rate of change is equal to average rate of change. Or it could be velocity. Instantaneous velocity is equal to average velocity. So usually that they can be in term velocity. Right? They can be in term velocity. So those are all like a very similar to mean value theorem. And the way they ask, they're going to say is, when is average rate of change equal to instantaneous rate of change? Basically, they are asking kind of like a mean value theorem. Okay. And the reason why that's important is because this actually have to form all the connections. When you do the math part is super easy. The math part is super easy to understand, but the mean value theorem is very, very important. Why? Let's look at it why. if they don't have to be at the same height, right? If let's just say A is right here, B is right here. They don't have the same height this time, but they are continuous. And we're going to draw a one peak situations. So the secant line is going to be like something like this. Oops. The secant. But the tangent, somewhere along the line here, I think right in this spot right here. Somewhere there, it's going to have exact same slope. This is the tangent. So they will equal each other. And it can happen more than once. Why? Because what if I draw a second situation, like the two peakless situation like this? You can have happen here, and you can have here. That's still equal to the secant line. Does that make sense or no? Yes? And the way they ask questions is phenomenally good because AP exam, they come up with questions very, very creative to ask. Is you have to see it. But first of all, I'm going to teach you how to see those things. Because when you see it, so you can actually go into the Desmos and you can just say, well, let's go to Google. That's the best thing is to search Google and just type in mean value theorem and Desmos. And because the problem is sometimes there's no math involved. And just by seeing things, we're going to show you how this works. So mean value theorem, Google, like this. We have two secant line here. So we're going to change, I really don't like this function like this. Let's change it like this. Okay. So let's go with, oops. Something like this. So there is a secant line of the functions. And if I go in through here, you see the color change, okay? So pay attention. So the tangent line here is going to be really steep, really steep. Do you see there's something changed there? No? You know what? This is a very crappy function. Let's do this one. Okay. So, C. Nope, C is right here. A, B. Okay. So go like this. So you see that there is a tangent line at one point. Oops, like that. I'm gonna play it. Play the C. Oops, no, I don't want to play the C. That's bad. Okay, I'm gonna play this A maybe, and I'm gonna play it slowly. See the color change? No, you don't see color change? It's supposed to have a color change. Let's restrict the value between, between -4 to 2. And let's play it. So there's somewhere there's the red line is gonna be exactly equivalent to the black line, the slope wise. But you have to be very, very patient to see that. Let's see if we can somehow get there. Right. And it can happen more than once depending on how many hump inside the curve. So almost there. You see that almost there? It has to be once. It's supposed to have a color change, but at here it's pretty much the same. The slope is exactly the same. You see this line is probably not going to intersect. It still intersect. It's still going, so maybe more. It's supposed to have a color change. I remember they're supposed to have a color change, but every time when it go lit, it's going to have a color change.
Just make it easy, set them equal to each other so it's a zero slope.
And then that'll be Rolle's theorem. So that's why you have to have the same height to Rolle's theorem, because secant between 2 points, FA equal to FB, that's why the F prime of C is equal to 0. So that's actually Rolle's theorem, not mean value theorem, right? If they both are equal to 0. So those are the idea that what you can do. So what happened with mean value theorem is very interesting questions. So we can answer all this question very, very good. So we're gonna pull out a mean value theorem and Rolle's value theorem. So mean value theorem. And see, this kind of question has nothing to do with calculations. We're gonna show you. So those are the questions, nothing to do with calculations. And there was a calculation. Let me erase all of them because I worked out last year. So this is a mean value theorem. So we're just gonna go straight to mean value theorem because Rolle's value theorem basically just if they are the same, they should have a derivative. So I hear that you see here. So let's say 2. Let's look at the question 2, right? If you got an answer, don't say it. I want you to look at it. This says on the closed interval a and b, how many point mean value theorem does satisfy? There's no calculation. I know you know it. I need other people to see it too. There's no calculation. So a lot of time math, AP exam, how many times you seen AP exam has nothing to do with calculations? And this type of question has nothing to do with calculation. It's to be able to see tangent and secant line. Mandy, what do you think?
I was thinking either 2 or 3.
So what do you think? Is 2 or 3?
2.
You think it's 2? Okay. Julia, what do you think? 3. Ashbrook, what do you think? Matthias, what do you think?
I thought it was 2, but
You thought it was 2?
yeah.
Tyler?
I thought it was 2.
You thought it was 2? Okay. Nisha? You think it's 3? Connor?
3.
Eva? 3. Okay, so the answer is 3. But there's no calculation on this type of question. How the hell are you supposed to figure out it's 2 or 3? That's why you have to go through a decimal and to see how things work. So if this is a tangent line, right? At this point here, you have to be able to see that tangent. At this point, it should have same slope. Here you should see the same slope. Here you should see the same slope. And there's no calculation involved. There's nothing you can do. Yes.
You can kind of think of it to see how many are like once you draw the secant line, each time you're gonna have a tangent is like a mini Rolle's theorem where when it crosses like the middle hump, when the secant line intersects the 2 points on the ends of the hump, that's basically just Rolle's theorem because they equal the same value, so there has to be a slope to those 2 points.
Now, do you see why I think Lagrange really stole the Rolle's theorem? Just take away the conditions. F of A equal to F of B. Like he kind of just take this and kind of tilt the paper a little bit. It's like, okay, we're gonna get rid of. It's pretty much what he did because if the paper is straight, then you have 2 points the same. If we tilt the paper a little bit, guess what? The 2 point doesn't have to be the same, but the idea is still the same. Do you see what I'm trying to say?
Yeah.
Okay, so those are the things. So there is no math involved. And why is the conditions really important? Let's look at the question 1. There's no math involved here. You have to understand the ideas. Don't say the answer if you know it. How many of those conditions does not satisfy condition of mean value theorem? We're not doing math today. We're just doing the conceptually understanding. Robert, what do you think?
I think
You think 2? Can you tell me which 2 and why?
I think the second, wait, hold on. No, I think 3. I don't think the first one satisfies it because the endpoint is, like, I don't think the limit exists there.
Okay.
The second one has a sharp turn. I think the third one satisfies it. And then the fourth one is not continuous.
So therefore, you have to understand each individual one. So like say, the last one's not continuous. The second one's not differentiable. The first one is not continuous at the endpoint because the endpoint is open circle. So it's supposed to be close parenthesis. So those are the things you should logically thinking. So those questions has no calculation involved. You have to figure out how things works. Does that make sense? The calculation is really easy. I think anybody can do the calculation. Let's look at this. This is another question that has no calculation involved. But then you have to know what the function look like. If you got answers, just raise your hand so I can call you. Nicole first.
A, because you're setting your sharp turn is an absolute value.
Okay. Connor says different.
I think B 2 doesn't work either because it doesn't exist at 0.
There was an asymptote. Okay. How about 1, 2, and 3? Is that possible? No?
I don't think sine of 2x is. I think it's continuous and differentiable.
Right. So those are the things that you should have to recall. So it's not only the math that you gotta be able to do. You gotta not only be able to outdo the algebra, because the algebra doesn't really help you in any of those 3 questions. On AP exam, there's a lot of those type of questions that doesn't involve math. You have to understand fundamentally, understand how his theorem works. Mandy, does that make sense? Okay. We can try another one. Ooh, this one is actually interesting.
Does that just say 1 for x is less than -1?
Mm-hmm. That's equal to -1.
Oh, okay.
You actually had to draw it out in this type of situation. And the wording and the parentheses is very close to each other. On AP exam, you have to outdo all those stuff. You have to see all the stuff. Luke say you got an answer? Yeah, what do you think the answer is?
E, because the rest of them are not true.
Okay, let's go over why it's not true. Okay, so first of all, let's draw it, right? So a lot of time you had to be able to draw it. At -1, anything less or equal to -1 is going to be a solid circle, is like this. Does that make sense? Good? Okay. And x, when x greater than -1, so x greater than -1, it's going to be open circle this way. Okay. So that does not satisfy its conclusion. The mean value theorem, closed interval between -1 and 1, is because what?
Not continuous.
But D doesn't make sense, right? Not continuous. It is continuous at D between open parenthesis of -1 to 1.
Continuous from the endpoints.
So D is not right. How about C?
That is true.
No, because that excludes the endpoint, so the other part of that is differentiable.
It is differentiable.
Yeah.
It's wrong because it's true. Like, that it is okay to do it.
I think you're saying it was.
Does that make sense? F of it negative 1, does that exist?
It does.
It does, right? So those are the things that you had to go through. In calculation-wise, I'm gonna let you guys figure out how to do calculations because calculation is not hard. The conceptual is harder.